Here is something that should bother you. Almost every AI agent you have ever seen in a demo is dead within months. Not because the model was weak, the model was fine. They die because a demo is a model with a prompt, but a product is a model with a system around it. And almost nobody teaches the system. So today, we fix that properly. This is a full engineering session on agent system design. I am going to draw the entire architecture of a production AI agent on one master blueprint, live, piece by piece. One core loop in the middle, and the 7 subsystems around it that decide whether your agent survives contact with real users. Orchestration, context and memory, tools, guardrails, instruments, power, and the chassis. This is the same anatomy behind every serious agent shipping right now, from coding agents to support agents. And by the end of this video, you will be able to look at any of them and read the architecture the way an engineer reads a drawing. And the finished blueprint, the exact sheet we draw today, plus a design checklist for every single layer, is a free PDF. Comment the word blueprint, and it is yours. The sheet is on the table. Let's draw. Before we draw anything, we have to agree on what an agent actually is, because that word is doing a lot of dishonest work right now. Strip away the hype, and an agent is 3 things in a loop: a model that can think, tools that can act, and a loop that keeps going until the goal is done, with the model itself deciding what happens next. That last part is the whole trick. Anthropics researchers draw a hard line here, and it is the most useful line in this field. If your code decides the path and the model just fills in the steps, that is a workflow. If the model decides the path, choosing its own steps and its own tools as it goes, that is an agent. And here is the design rule. Almost everyone breaks on day one. You do not start with an agent. You start with the simplest thing that works. Because every decision you hand to the model trades away predictability and adds latency and adds cost. Workflows are cheap, fast, and testable. Agents earn their keep on exactly one kind of problem: the open ended kind, where you cannot predict the number of steps in advance. So, that is the first thing on our sheet: the core. One model wired to retrieval, tools, and memory, running in a loop with a clear exit condition. Now, let's build the 7 subsystems that keep this loop alive in production. Subsystem 1: Orchestration. This is the decision layer. It decides how much freedom the model actually gets. And there is a menu of 5 proven patterns in order of increasing freedom. Pattern 1: Prompt chaining. Break the task into a fixed sequence of calls, where each call cleans up after the last. Draft, then critique, then polish. Boring, reliable, use it everywhere. Pattern 2: Routing. A small model reads the request first and sends it down the right lane. The refund question goes one way, the technical bug goes another, and each lane gets a prompt that is actually good at its one job. Pattern 3: Parallelization. Split the work and run it at the same time, or run the same question several times and let the answers vote. Pattern 4: Orchestrator and workers. One lead model reads the goal, breaks it into subtasks it invents on the fly, and hands them to worker models that each come back with a clean result. This is how serious coding and research agents work today. And pattern 5: the evaluator optimizer loop. One model generates, another model judges, and the work bounces between them until it passes. That one pattern, generator plus judge, quietly powers a huge share of the quality you see in shipped AI products. And here is the architect's move. You rarely pick just one. Real systems nest these: a router in front, workers behind it, a judge at the end. Draw the lanes first. Freedom is something you grant the model one lane at a time, not all at once. Subsystem 2: Context and memory. And I will say this plainly: this is where most agents actually die. Not in the model, in the context window. Here is the mental model. The context window is not storage, it is the model's working memory, its attention budget. And every single token you stuff in there spends a little of it. Anthropic's engineers have a name for what happens when you fill it up: context rot. Past a point, every extra file and every extra instruction makes the agent measurably dumber because attention is being smeared across everything instead of focused on the thing that matters. So, this subsystem is really a discipline: what enters the window, what waits outside, and what gets written down. Move 1: get your system prompt to the right altitude. Not so rigid that it is 1,000 brittle rules, not so vague that the model has to guess what you want. Strong heuristics, minimal law. Move 2: just in time context. Do not preload everything the agent might need. Give it lightweight pointers, file paths, queries, links, and tools to pull the details in at the moment they matter. Move 3: compaction. When the window fills up on a long task, summarize the conversation and restart the window with the summary. And move 4: the one that separates toys from systems. Notes: the agent writes what it has learned and what remains to be done to memory outside the window. So progress survives even when the window resets. Working memory inside the window, long term memory outside it. And draw the pump between them because that pump is the actual product. Subsystem 3: tools. Tools are the agent's hands. And here is the uncomfortable truth: most agent failures that get blamed on the model are actually tool design failures. There is a real discipline here, and Anthropic's team gave it a name I love: the agent computer interface. User interface design. This is that. For a user, that is a model. 4 rules. Rule 1: fewer, sharper tools. 10 overlapping tools that half do the same thing will confuse an agent exactly the way a junk drawer confuses you. If a human engineer could not say instantly which tool to grab, neither can the model. Rule 2: write the description like documentation for a brilliant new hire who has zero context. What it does, when to use it, when not to use it, with an example, edge cases included. Rule 3: design the returns. When a tool fails, do not return a bare error code. Return what went wrong and what to try instead, because that message is the only thing the model can act on. And rule 4: keep formats close to what the model has already seen a million times out in the wild. Natural text, standard formats. Do not invent an exotic syntax that burns the model's attention on formatting instead of thinking. On the sheet, this is the tool bay: a few clean sockets, every socket labeled, every wire documented, small surface, sharp edges. That is what reliable hands look like. Quick pause, right on schedule, because look at what we just drew. Every serious system has a feedback signal, the wire that tells it what is working, so it can do more of it. This channel has one too, and it is the subscribe button. Real talk: 90% of you watching haven't subscribed. On Facebook, subscribe is the supporter button, so that is what keeps the lights on here. On YouTube, it's free and it tells the algorithm to send you more. Subscribe to support us. Okay, wire drawn. 4 subsystems to go, and the next one decides whether you ever sleep at night. Subsystem 4: Guardrails. Here is the question that defines this layer: what is the worst thing your agent could do at 3 in the morning with nobody watching? Because whatever your answer is, that is what you are designing against. Guardrails come in rings. The outer ring is permissions, least privilege, exactly like you would give a new employee. The agent gets access to what it needs for the job, and not one table more. Read access before write access. Sandboxes before production. The middle ring is validation. Check what goes in. So a malicious user cannot inject instructions that hijack the loop. And check what comes out before it becomes an email, a refund, or a deleted database. And the inner ring is the one that matters most: the irreversibility line. Draw an actual line through your action list. On one side, actions that are cheap to undo. Let the agent run. On the other side, actions you cannot take back. Money moved, messages sent, data destroyed. And on that side, a human approves before the action fires, at least until trust is earned. Then, around the whole thing, breakers. Caps on spend, caps on loops, caps on time. So a runaway agent trips a fuse instead of burning the house down. Full autonomy on day one is not confidence, it is negligence with better branding. Autonomy is earned in rings from the inside out. Subsystem 5 Instruments, Evaluation and Observability. And I will give it to you as one sentence. An agent without evals is a rumor. You do not actually know that it works. You know it worked the last few times you happen to be watching. So we instrument the machine in 3 panels. Panel 1 Traces. Every run of your agent should leave a flight recording. Every model call, every tool call, what it saw, what it chose, what came back. When something goes wrong at step 9, you replay the tape instead of guessing. Panel 2 Evals. Evals are unit tests for behavior. Collect real tasks with known good outcomes, and 20 is enough to start. Then score the agent against them on every single change. And grade outcomes, not paths. Did the task get done? Not did it match your favorite route, because agents legitimately find different valid routes to the same result. For fuzzy outputs, use a stronger model as a judge with a written rubric and spot check that judge against your own opinion until you trust it. Panel 3 The drift needle. The live production numbers, task success, human takeovers, cost per task. Watched over time because the world changes underneath a deployed agent, even when you change nothing. And here is the payoff, the whole reason this subsystem exists. With instruments, improvement becomes engineering. Change one thing, run the evals, read the needle. Without them, you're just vibing in production. And production always wins that argument. Subsystem 6 Power, Cost, and Latency. The subsystem everyone ignores until the first invoice arrives. Remember, an agent is a loop, and loops multiply everything. A workflow calls the model once. An agent might call it dozens of times for a single task. So every waste you tolerate gets multiplied by the loop count. 4 regulators go on the sheet. Regulator 1 Model routing. Match the model to the step, not to the product. The hard reasoning steps get the big model. Classification, extraction, formatting, and summarizing get a small, fast one. Most steps in most agents are small model steps, and routing them properly cuts real money with zero quality loss. Regulator 2 Catching. An agent rereads its own system prompt and its tool definitions on every single turn of the loop. Prompt caching makes that repeated part nearly free, and on long agent conversations, it is one of the cheapest wins in the entire design. Regulator 3 Parallelism. Independent calls should never wait in line. Fan them out, and latency stops being the sum of all your steps. And regulator 4 Budgets. Give every task a token budget and every loop a turn limit, enforced by code, not by hope. When the budget runs out, the agent stops, reports where it got to, and asks. Here is the pattern to internalize. Intelligence is the expensive resource in this machine. You spend it exactly where it changes the outcome, and you meter it everywhere else. Subsystem 7 The chassis, reliability. The difference between an agent that works and an agent you can bet a business on. Here is the situation nobody designs for. Your agent is 40 minutes into a task. It has made 100 decisions, and the process dies. Network drop, timeout, deploy, whatever. What happens now? If your answer is it starts over from zero, you do not have a system yet. You have a very expensive slot machine. So, chassis parts. Part 1 Checkpoints. The agent's state, the plan, the notes, the work. So far, persists outside the process. So a crash resumes instead of restarting. Part 2 Safe retrace. Everything fails sometimes. so everything gets retried, which means every action must be safe to attempt twice. One flaky network call must never become two refunds. Part 3. Degraded modes. When a tool goes down, the agent should narrow, not collapse. Say what it cannot do what it still can, and hand off cleanly to a human when it is truly stuck. And part 4, the one nobody does until it burns them. Version everything. Prompts, tool definitions, model choices. Pinned and versioned like code. Because a silent prompt edit on Tuesday is how you spend Wednesday debugging a ghost. Is all of this boring? Completely. But boring is a compliment in systems engineering. The chassis is the reason nobody ever tweets about your agent failing. And there it is. Pull the camera back and look at the whole sheet. Because when we started, this was an empty grid. One core, a model, tools, and a loop. With an exit. Orchestration. Granting freedom. One lane at a time. Context and memory. Defending the attention budget. Tools. A small bay with sharp documented edges. Guardrails in rings with a hard line at the irreversible. Instruments. So improvement is engineering instead of vibes. Power, spending intelligence. Only where it changes the outcome. And the chassis. So a failure is a checkpoint. Never a restart. Now notice the thing that should change how you see this entire field. The model is one box on this sheet. 1. Everything else is just engineering, which means everything else is learnable. And it also means the next model release does not make any of this obsolete. Better engines drop into good chassis. So here is your new reflex. The next time someone shows you an agent, do not ask which model it runs. Ask where the blueprint is. Ask what happens when a tool fails. Ask where the irreversibility line sits. Ask what the evals say. You will know more about whether that agent survives than any demo will ever tell you. That is the difference between someone who prompts and someone who designs the system. And as of right now, you are the second kind. So here is everything on one page. The finished blueprint you just watched me draw, the core and all 7 subsystems, plus the checklist I actually use for every layer, the questions to ask before you ship, and the decision tree for workflow versus agent. It is completely free. Comment the word blueprint on this video and I will send it to you, or grab it straight from the link in the description. And if you are ready to go from reading blueprints to building your first real system, my paid beginner guides for Claude Code, for Codex, and for Claude at Work walk you through it hands-on, step by step. They are linked below too. If this video earned it, here is the move. Subscribe here on YouTube, and if these deep dives are worth real support to you, have a look at the membership. On Facebook, that is the supporter button. And the builds behind these videos live over on Instagram. Come see them. Now, do one thing tonight. Take one AI system you are building, or even just one that you use, and draw its blueprint from memory. 7 subsystems. Mark the boxes that are missing. And that empty space on your sheet, that is not a gap. That is your roadmap. See you in the next one.